Hello everyone, this is our fourth video of internal video explanation series. In this video, we will going to solve the questions of k-mean clustering and association rule mining algorithm. Let's start. This is our question paper of internal test 2 of day 2. Question number 1 is suppose you are given following data items to cluster 2, 4, 10, 12, 3, 20, 30, 11, 25 and k is equal to 2. Using Euclidean distance computation, apply k-mean clustering and generate final clusters. Algorithm is also mentioned there. So solution is first given k is equal to 2 for 10, 12, 3, 20, 30, 11, 12 and k is equal to 2. It means we are considering two clusters. Now we are considering M1 and M2 two clusters. M1 is 4 and we will take M2 as 12 which are random values. We can take any random values from the set. Step 1 is we are writing those numbers in K which are closer to 4 as compared to 12 and put remaining numbers in K2. Then K1 is 0, 3, 4 and K2 is 10, 11, 12, 20, 25 and 30. Now M1 equal to 2 plus 3 plus 4 by 3 which is equivalent to 3 and the value of M2 is 18. Step 2. Now in K1 we are taking those numbers which are closer to 3 as compared to 18 and we will put remaining numbers in K2. So now our K1 is updated and values are 2, 3, 4, 10 and values of K2 are 11, 12, 20, 25, 30 and M1 is 4.75 and M2 is 19.6. Similarly, step 3. Now in K1 we are taking those numbers which are closer to 4.75 as compared to 19.6 and we will put remaining numbers in K2. So K1 is 2, 3, 4, 10, 11, 12 and now K2 is 20, 25, 23 and now M1 is 7 and M2 is 25. Now in step 4 we are going to again taking those numbers which are closer to 7 as compared to 25 in K1 and we will put remaining numbers in K2. So now K1 is 2, 3, 4, 10, 11, 12 and K2 is 20, 25, 23. Exactly same in now M1 is 7 and M2 is 27. We are getting same means. So the new clusters are K1 is equal to 2, 3, 4, 10, 11 and 12 and K2 is 2, 20, 25, 30. Next question is consider the following transaction data. T1 equal to bread, jelly, peanut butter. T2 equal to bread, peanut butter. T3 bread, milk, peanut butter. T4 bread and beer. And T5 is beer and milk. Support is given of 30% and confidence is 50%. Now using association rule mining a priori algorithm, we will create frequent item set table. In first column item, second column has frequency of that a particular item, and in third column we will write support. We will find out support by using the formula number of occurrence of a particular item divided by total number of transaction. After finding all the support, we will compare minimum support with each item support, and if item's support is less than 30 we will omit out. So after comparing the we will omit out jelly from association rule mining process because its support is less than 30. Now after removing jelly we will create a new data set. Now, in step 2, make two items candidate set and wrote their frequency and find out their supports. And after finding supports, again we will compare the support with each item's support uh, who is less than, greater than 30. then we will omit out that particular item from the data set whose support is greater than 30%. So bread and peanut butter has a support more than 30%. The occurrence of bread with peanut butter is 30. Now, now we will generate rules. So for rules, we have two conditions, bread, peanut butter, and peanut butter bread. The final rule will depend on the confidence of the rule. We will find confidence by using confidence from A to B is equal to support of A union B divided by support of A. First rule, we will use first rule, bread to peanut butter. So, support of bread and peanut butter divided by support of bread is 75%, and peanut butter to bread is 100%. So confidence of all the pairs are greater than 50%. So all the rules are good because according to the a priori algorithm, if confidence of rules are greater than actual confidence, so those rules are valid. Now, next part. In this table, we have given transaction IDs and list of item IDs. And minimum confidence is 70 and minimum support is 2. We will create first item set and frequency and write frequency on the table. So item 1 is 6, item 2 occurs 7 times, 3 occurs 6 times, and 4 occurs 2 times, and 5 occurs 2 times. Now we will create second item data set. So item 1 2 occur 4 times, 1 3 is also 4 times, 1 4 has occurred 1 time, 1 5 has occurred 2 times, 2 3 is 4 times, and 2 4 has 2 frequency, 2 5 has 2, 3 4 has 0, and 3 5 has 1, and 4 5 has 0. Now we will compare the frequency with minimum support. If their support is less than 2, then we will remove them from table. So 1 4, 3 4, 3 5, and 4 5 has support less than 2 0. Sorry, less than 2. Now after removing those three item pairs, we will create a new table, and now we will create three item pairs data set. So item sets 1 2 3 has 2 frequency, 1 2 4 has 1, 1 2 5 has 2, 1 3 4 has 0, 1 3 5 has 1, 1 4 5 has 0, 2 3 4 has also 0, 2 3 5 is 1, and 3 4 5 is 0. Now we will check the frequency or support of those elements, those item data sets in table which support are greater than 2, and we will remove them from the table. So item set 1 2 3 and 1 to 5 has minimum support greater than 2. Then we will create a new table for those item sets and find their support. So 1 2 3 item pair has 2.22 support, and 1 to 5 has also 2.22 support. Their support are same. Now we will create four items data set. So in a given data set, we have only one pair of four items. So frequency is 1 and their support is less than 2. So we will also omit out this. So after omitting it, three item data sets are now actual item set. So let's consider I1 is equal to 1 2 3 and I2 equal to 1 2 3. These are I1 set has 1 2 3 element and I2 set has 1 2 3 element. Now, we will create their non-empty subset. So, for I1, there is subset S1, which has elements 1, 2, 3, 1, 2, 1, 3, and 2, 3. And in I2, uh, the subset S2 has 1, 2, 5, 1, 2, 1, 5, and 2, 5 elements. We for next step uh, we will use association rule. So how to form association rule? For every non-empty subset S of I, the association rule is S I to S if support I divided by support S is greater than equal to minimum confidence, then rule is valid. Now, association rule mining or subset creation. So, frequent three item data sets. I1 has 1, 2, 3 items, and their non empty subset are 1, 2, 3, 1, 2, 1, 3, and 2, 3. Rule number 1, 1, 2, 2, 3. Confidence is 3, 33.33, which is less than 70. So this rule is invalid. Now from 2 from 2 to 1 3. So its confidence is also less than 70%, less than to 70%. So this rule I2 from I2 and I3 is invalid. Now rule 3 from 3 to 1 2, the confidence is 3.33 is which is also less than 70%. So this is also invalid rule. Now rule 4, 1 from 1 to 3. So its confidence is 50%, which is also less than, it is also invalid rule. Now rule 5, 1 3 2 2. 50%, it is also invalid rule. Rule 6 is 2 3 to 1, and its confidence is also 50%, which is less than 70%. So this is also invalid rule. Now we will go to the next item set, which is 1 to 5, and their non-empty subset are 1 to 5, 1 to 1 5 to 5. Rule number 1, from 1 to 2 5, confidence is 3.33, which is less than 70%. This is also invalid rule. From 2 to 1 5, confidence is 28.57, also less than 70%. This is also invalid rule. Rule 3, from 5 to 1 2, their confidence is 100%. So this is valid rule. Now rule 4, from 1 to 5, their confidence is 50%, it is less than 70%. This is invalid rule. Now rule 5, from 5 to 2, confidence is 100%, which is greater than 70%. So this is valid rule. And rule 6, from 5 to 1, their confidence is 100%. This is also very valid rule. So from I5 to I1 and I2, and I1 and I5 to I2, and I2 and I5 to I5 are valid rules. Thank you.